Hey guys, welcome back to our segment routing traffic engineering series. In the last couple of episodes, we have been talking around TI-LFA, and specifically in the last episode, we talked about the SRLG concept. SRLG stands for Shared Risk Link Group, and we went over the theoretical concepts, looked up the SRLG and some of the things. In this particular episode, we'll go ahead and do some hands-on around, and first of all, I want to apologize, missing the couple of videos. I've been pretty busy with one of my current implementation, so finding time from the implementation is slightly difficult, and I might miss maybe a couple more episodes down this week, but hoping from next week I will be again back to our regular schedule. But anyway, coming back to our topic of SRLG. So before we really deep dive into the hands-on of SRLG, we need to go ahead and understand a few more things, and we briefly touched upon some of those things in the previous episode also. So I'm continuing again, segment-routing.net, the PDF. So based on that, we kind of know there are a couple things we can go ahead and protect using TI-LFA. There is a link, node, or SRLG. And again, node and SRLG protection automatically implies that, we are protecting our link also. And we have seen these example, okay, we are trying to protect a link, a node, and then we saw an example for the SRLG, where we would go ahead and assign a couple of the links into the same group that would indicate a shared risk. So that means if one of the link go down in that group, we assume that the second link will also go down, and we would like to have a path calculated by avoiding these two links or our SRLG group. So just to continue further, we need to really understand there is one more thing in the SRLG or in the TI-LFA, that is something called the tiebreaker rules. So let me go ahead and scroll down a couple of the slide. But before that, it says, okay, hey, TI-LFA uses something called a tiebreaker configuration to specify preference. And the preference is really the order of protection mode, whether do we want to protect link, node, or SRLG. And it clearly says link protection always has the lowest preference, and this is something you cannot go ahead and configure that. And there is another thing, OSPF-IS is most preferred as the highest index. That means when you are working with this tiebreaker rule, we will go ahead and explore a concept of index. That means higher the index, and that thing would be more preferred. That means for a given thing, if we are trying to configure, let's say, both a link as well as node or SRLG, now if your SRLG has a highest index, that means that will be your mode of protection. That means you'll go ahead and protect your SRLG followed by node and vice versa. So here it shows an example, okay, hey, when we go ahead and configure fast reroute, so far we have been doing fast reroute prefix and TI-LFA. Now we'll go ahead and introduce this concept of tiebreaker. So in this case, if you see the tiebreaker, we are configuring the TI-LFA both for node as well as for SRLG. And for SRLG, index value is 100, and for node protection, the index value is 200. So now if you go ahead and scroll down here, further couple lines. So what it says, if node protection is possible, and a local SRLG. So there are two types of SRLG. There is something called local SRLG. There is another called remote SRLG. And we might explore this into some of our upcoming episodes. But what is trying to say here, if node protection is possible and local SRLG protection is possible, that means both are possible, but not concurrently. That means you cannot do both at the same time. Then the tiebreaker preference index indicates which one to select. And we just saw that the tiebreaker index. So when you are configuring the tiebreaker, we will go ahead and assign an index value. So in this case, SRLG has an index value of 100, while the node protection has an index value of 200. And the logic is very simple. It says, okay, hey, if the node protecting index value is greater than your SRLG disjoint index, then node protecting, then you will go ahead and protect the node. Otherwise, you will go ahead and protect the SRLG. Is as simple as that, guys. So remember, there is a tiebreaker rule that comes into the picture, and why do we need? Because there are situations sometime when we'll go ahead and do a couple of the SRLG configuration, and that's where this index will really come into picture to see, okay, which one needs to be preferred over the other one. So that's where this tiebreaker rule will come into the picture. Now with that, let's go ahead and jump onto our topology, and we will go ahead and talk about something. But before I do that, let me go ahead and potentially keep this screen open here, and we'll go ahead and talk about that. So for this particular hands-on, our topology is like this. We have 6 router here, router 1, router 2, router 3, router 4, router 5, router 6. So in this case, router 1 is trying to reach to router 6, or let's say, in this case, the router 2 has two links, one link going to router 4.1, which connects to our router 6. The router 2 has another link that goes to router 5. That means if this link, the link between a router 2 and a router 4.1, if this particular link, we are saying, okay, hey, if this particular link between router 2 and router 4.1 happens to fail, that means we will not be able to reach to router 6. Okay. So in that case, we are saying, okay, hey, if this link between router 2 and router 4.1 fails, we want you to treat the link between router 2 and router 4 also is like failed. That means we're going to configure both of these links into the same SRLG or same shared risk group link. That means when this link fails, we want this to be treated as a failed, and then we want the TI-LFA to figure it out an alternate path to reach the router 6. So in that case, if you see, the only path that we left with is literally going to router 3, to router 4, 5, from 5 coming down to 4, and then from go to router 6. So we are trying to say, okay, hey, just simply if this link fail, just avoid this link also for the calculation. So for that, let's go ahead and start doing the configuration. I just brought up this topology, so I do not think so I have configured the segment routing. Let's go ahead and configure that. If not, we'll go ahead and quickly. Okay, I do not have the configuration, guys, so give me 1 second and I will go ahead and start doing the configuration. Okay, so let's go ahead and configure our router 1. First, with segment routing, we are assigning an index value of 1 here. Let's commit the change, come out from router 1. Now let's log into our router 2 and we'll go ahead and do the similar configuration on router 2 here. Let's go ahead and assign a prefix index value of 2 to this particular router. Commit the change, come out. Let's go to the router 3 in this case. And we'll go ahead and say Cisco and configure the password. Now let's go ahead and assign an index value of 3 to this router. Commit the change, come out. Let's go to our router 4.1. Let's go ahead and assign an index value of 4 to this router. And by this time, I'm sure you all are familiar in terms of configuring the segment routing and basic configuration. Now let's go to our router 5. We'll go ahead and do the similar configuration on our router 5. We'll go ahead and assign a prefix index or prefix set of 5 to this router. Let's commit the change, come out, and let's go to our router 6, which is the last router in our topology. Let's go ahead and configure that router also with a prefix set index value of 6, and then let's commit the change. Let's come back to our router 1 and just quickly, or maybe we can just stay on router 6 and just take a look at our MPLS forwarding table. Okay, so we can see we have all the different prefixes being advertised, so that part is good. So now at the moment, let's go to our router 2. We'll go ahead and do this configuration on router 2. So at this particular moment, if you go ahead and just simply take a look at few things here pretty quick. Okay, so we are trying to see, what do we see? Do we have any existing stuff? So let's do show ISIS fast readout to our router 6, 192.168.0.6/32, and go ahead and do a detail here. You can see right now we do not have any FRR links. There is only one link that is traversing via router 4, means router 2 sends the traffic to router 4, as you can see from here. And that's all. It's pretty much it is taking and it is going out. There is no problem. So that indicates, okay, hey, we do not have anything. We can also go ahead and look at our rib table, guys, for the same thing. So we can do show route for 192.168.0.6/32. We can go ahead and do simply detail here. And looking at our rib table, again, we do not have any backup paths or anything. There is one path which it clearly says, okay, hey, it's a labeled SR and it is taking this particular path, and this is the path index and some of the other things. So that means we do not have anything also in the rib table. We can also take a look at our fib table if you want. So let's go ahead and quickly verify by doing the show ceph 192.168.0.6/32. Let's just simply go ahead and press enter. And again, in this case, it says, okay, hey, we do not have any backup path. and there is only one path which is taking over this particular gigabit Ethernet interface, and this shows happens to be our next hop. So at the moment, this is we have no configuration of any nature or anything configured on this particular router. So let's go ahead and configure. The very first thing we will go ahead and configure on this router. So if you remember, just to recall, if we go ahead and configure a TI-LFA, okay, and if we configure a TI-LFA for this particular link, that means if this link fails, that means it will go ahead and potentially use this particular link to reach to router 6. Okay, we can go ahead and confirm that, guys. So we are on router 2. So this particular link is our link number 3, and you can take a look at here, doing by the show configuration here, and router 4.1 is the link number 3. So let's go ahead and configure the TI-LFA for this link. So we'll go ahead and say router IS as 1, and then we go to our interface gigabit Ethernet 004 address family IPv4 unicast, and we'll send a fast readout based on per-prefix, and then we want the algorithm needs to be TI-LFA, and let's go ahead and commit the change, guys. And if you come out now, so what we just did here, just to quickly show you again here, we just went ahead and enabled the TI-LFA for the link between router 2 and router 4. So this is the configuration we did. This is the link between router 2 and router 4. For this link, we went ahead and configured the TI-LFA. Now, if you quickly take a look at some of those outputs that we ran earlier. So now let's take a look at the fast readout first. So now the fast readout says, okay, obviously, hey, there is no backup or anything right now. Okay. Now let's take a look at the show fib table here. We do not have anything in this particular table also. Okay. Why do not we have anything? So we can take a look at here the configuration one more time. Okay, let's take a look at again. Okay, guys, so here is the issue why we do not have TI-LFA, because if you remember, the link between router 2 and 4 is interface 3, and I happen to configure that on the link number 4. So let's go ahead and correct that. So we'll go router IS as 1, the interface gigabit Ethernet 4, because for this interface it is not connected right now because it is connected to the router which I have powered off for. We are not using them in this particular topology. So let's go ahead and take them off completely. So we'll go ahead and change, make a note to this one also, commit the change. Now let's go ahead and configure on the correct interface, that is interface gigabit Ethernet 03, and let's go ahead and apply address family IPv4 unicast. Let's go ahead and apply this configuration to this interface, and now let's go ahead and commit the change. So this time we should have the correct interface. Let's go ahead and verify that one more time that I did apply to the correct interface. Yes, I have applied this time to correct interface. Now let's go ahead and take a look at our fast readout. So we are doing show ISIS fast readout for this particular interface. Now, as you can see, as expected, there is a backup path, and this backup path is based on LFA, and it says, okay, hey, the primary link it will use 003. That means it'll use this link. If this link happens to fail, it'll go ahead and switch it to gigabit Ethernet 02. That means it will go ahead and switch it to this link. And as you can see, this link is sending the traffic to router 5. So it will go ahead and send the traffic to router 5. And from router 5 knows, okay, how to reach this prefix set, which happens to be the prefix set of our router 6. So that means we know, okay, hey, if our initial link, the initial path from router 2 is taking this link between router 2 and router 41, and then between router 41 and router 6. But if this link between router 2 and router 41 fails, our alternate path would be between router 2 to router 5, router 5 to router 41, router 41 to router 6 in that case. So as you can see right now, our LFA is working. But we are really interested into, hey, we know the LFA works. But now we want to go ahead and configure SRLG. That means I want to go ahead and configure this link between router 2 and router 41, as well as the link between router 2 and 5 into a same SRLG group. So that means if this link fails, I want TI-LFA to go ahead and exclude both of the link and figure out a different path. So for that, let's go ahead and configure SRLG. So to configure SRLG, we'll go ahead and type the command SRLG. And once you go inside the SRLG, there are a couple things that we need to go ahead and do that. First of all, we can go ahead and configure something called, there are two ways. I will go ahead and show you both the ways, and then I will tell you what is what. So now when you are inside the SRLG, we'll go ahead and pick a interface here, okay? So now the interface that we are interested in working in, the route interface 3 and your gigabit Ethernet 2. So I'm saying, okay, interface gigabit Ethernet 02. So once you're inside the interface, so there are a couple things. It says there is an index number for this value, as well as there is something called a name. Okay. So now we will go ahead and use something called an index value. So now you go ahead and pick an index. Let's say the index in this case, I'm using maybe 2. Once you press a question mark after it says, hey, what is the value you want to assign to this index? Let's call it whatever. In this case, I'm going to go ahead and this is a numerical value. If you guys remember that group ID. So I'm giving index number 2 to this one and a value of 20. Now let's go ahead and do the same thing for other interface, which happens to be 3. And now they both have, I'm using the same index value and same group value. And once this is done, so what we simply went ahead and did, so if you do here show run SRLG, we went ahead and configured an SRLG group. In that group, there are 2 interfaces, and both of the interface have the same index value primarily, or same group value, which is 20. So now if at this stage, if I do show SRLG, it would go ahead and says, okay, hey, on this router, there are 5 interfaces. And as you can see, in front of router interface gigabit 2 and 3, we have a value 1, which says, okay, hey, the SRLG is turned on, and their SRLG value or the group value is 20 in this case. So that means your SRLG is active. You went ahead and configured SRLG. In that SRLG, there are 2 routers, basically, sorry, 2 interfaces, 2 interfaces which are participating. Now, if you remember that on this router, we have a TI-LFA also working. So when you have a TI-LFA and we are just trying to go ahead and do the SRLG protection. So the SRLG protection or the node protection really happens at the global level versus what we do the TI-LFA at the interface level. So like earlier, we went to gigabit Ethernet 3 and we went ahead and configured the TI-LFA. But to configure the SRLG or the node protection, we go ahead and do them at the global level. So now let's go ahead and configure the SRLG protection. So we'll go to router IOS-XR and then we'll go to our address family IPv4 unicast. And now here we go ahead and say fast readout, again same per-prefix. And now if you remember, we had talked about the tiebreaker. Hey, we'll go ahead and configure a tiebreaker, but we are not doing node here. So in this case, the tiebreaker will not do much, but we still need that configuration. So we'll say, okay, SRLG is disjoint. And after that, we have to go ahead and configure that index value, guys, we just talked about. So let's go ahead and give an index value of 100. And once that is done, let's go ahead and commit the change, come out. And if you quickly take a look at the change that we made. So at the global level on router IOS-XR, at the address family IPv4, we went ahead and configured fast readout per-prefix. Tiebreaker, we are saying SRLG disjoint, index of 100. That means tomorrow in this router, if we want to go ahead and protect the node, if we want SRLG to be the first order of preference, then means for the node, we would have to give a lower value less than 100 and vice versa. So now at this stage, our protection is enabled. So if you remember, let's go ahead and, okay, now let's go ahead and take a look at the fast readout first. What happened, what changed with the fast readout? So if you go ahead and press a fast readout, so guys, if you, okay, if I have to compare this output, let me go ahead and scroll it up for you just so I can show you, sorry. Okay, hopefully now you can see, that's good. So before, when we had only the TI-LFA configured without the SRLG, if you remember, the backup path was showing the LFA. Hey, we have an LFA configured, and in the case of LFA, if our primary path, which was via Gigabit Ethernet 3, if that failed, we would use the path towards router 5 using the Gigabit Ethernet number 2. And that's what it clearly says, okay, the backup path is based on the LFA. Now at this router R2's global level, we went and configured the SRLG. And after configuring the SRLG, we are looking at the same fast readout. Now what it says, okay, hey, now the backup path, our primary path remains same. It says, okay, primary path is using Gigabit Ethernet 3, and using that you are going to router 41, and from there you are reaching to this particular label. Now because of the SRLG, it says, okay, hey, now your backup path is based on TI-LFA SRLG. Okay, that means your SRLG is in effect. And now here it says, okay, hey, to reach to this guy, you are sending the traffic. Now if you take a look at our P node, if you remember from the past episode, now our P node, point of repair node, becomes 3. So it says, okay, hey, use this label to reach node 3 first. That means now it will use this link between router 2 and router 1, and then from router 1 to router, using this link, it will reach router 3. And then it says, once you reach router 3 knows how to route the traffic to this particular prefix. So it will go ahead and use this prefix and send the traffic. That means if this link fails for the SRLG protection, because we had configured the link between router 2 and 41 and the router link between router 2 and 5 in the same SRLG group, if something happens to one of the links, we want you to avoid the second link, and that's what the path is based on. Now it says, okay, this backup path is calculated based on this SRLG, and in that case, I will go ahead and avoid these two links completely, and the backup path would be via the router 3. In that case, the traffic, I'll send the traffic to router 1, router 1 send the traffic to router 3, and router 3 is our point of repair node. And once we are on our point of repair node, our router 3 knows how to reach this particular SID label, which is 16,006. So it'll go ahead and potentially forward the traffic to router 5. From 5 it will go to 41, and from 41 it will go to router 6. So as you can see right now, our TI-LFA SRLG is in place. Now we can go ahead and also take a look at our RIB table. So if you go ahead and do show route 192.168.0.6/32, and if you do a detail, and you can see here, now we have a backup path which is based on TI-LFA, and it says, okay, hey, your repair node will be router 3, which is the router 3's loopback 192.168.0.3. And once you are there, the metric for this path is says, okay, hey, 5. Once you're there, so these are the prefix, or these are the labels, the label stack it is going to use. So that means it will go to router 3 first, be using this particular prefix set, and from there I'll go ahead and send the traffic to this particular prefix set, which happens to be the prefix set of our router 6. And similarly, we can go ahead and also take a look at our Ceph table. So we can do show Ceph 192.168.0.6/32. And as indicated here, it says, okay, hey, there's the same thing. This will be the backup path is calculated via the TI-LFA. And this happens to be our next hop. Our repair node is again the router 3. And these will be the label stack. That's what it says. The labels imposed are, the first label in that is 16,003, and the next one is 16,006. Now, if you go back and take a look at the SRLG, show run SRLG. So in this case, we had talked about using a like an index value and a value 20, index value and a value of 20. So this is one of the old syntax. So when I say this is one of the old syntax, that is a legacy configuration primarily, guys. Nowadays, when I say we, like, Cisco documentation, or when I use in the field, I do not use this particular configuration. Though this is still a valid configuration, but this is considered a legacy configuration. And if you read some of the newer Cisco documentation, they would also say, okay, if you're doing new implementation or something, you should not be using this particular syntax, where we are giving an index value followed by a value, and that is something. Instead, Cisco is saying, hey, you should switch it to something called named SRLG, basically. So now I'm going to go ahead and change this configuration from legacy mode. Again, this is a valid configuration, but it's not encouraged by Cisco to use this anymore. If you have an existing something running, you're fine. And again, you can go ahead and change that also to named SRLG. So we'll go ahead and configure something called named SRLG. So for named SRLG, if you remember under SRLG, we had this name keyword, SRLG name for value mapping. So now let's go ahead and create a name, and let's say I want to give that name as, we can call it anything, whatever you want. Let's say, okay, these are my red links. I want to give a, name followed by a value, name red, and then we'll go ahead and configure a value. Let's go ahead and configure a value of maybe 30 to this interface. So now what we just configured, we configured a named SRLG. Now instead of index, now we do the same thing. Now we'll go to an interface gigabit Ethernet 0. Instead of assigning this index and a value, now we will go ahead and assign just simply this named SRLG. So the named SRLG that we want to configure under this is red. So we'll say name is red. Now let's go ahead and do the same thing for our 4 and say named is red, and let's go ahead and commit the change. If you come out, let's go ahead and do a show run on SRLG. So what we just did, I'm just showing you both the legacy as well as the newer configuration. Again, Cisco does not recommend or suggest you not to use this configuration. This is a legacy way of doing the configuration. So at this stage, if you see, there should not be any change to any of our things. If you take a look at, we are still doing SRLG, and if you want, we can also go ahead and get rid of our legacy configuration. So I can go ahead and say SRLG, and then we'll go under interface gigabit Ethernet 2, and just let's simply go ahead and remove this legacy way of configuring the things, and I will go ahead and remove that same from our 4 also. Now let's go ahead and commit the change, guys, and if you take a look at the configuration one more time, now this is the new way of configuration, and this is the recommended way of configuring, and this is called a named SRLG. The earlier one that I showed you earlier using this index and a numerical value, that is a legacy configuration, and again that is not recommended for new. Again, this has no impact. Again, let's go ahead and verify our backup path, and you would see there is no change to the backup path. Or okay, I missed to, I think, yep, I missed to configure the, okay guys, my bad, I'm just typing 4 instead of 3, not sure why. So let's go ahead and fix that again. Okay, we'll go ahead and remove this particular interface. We do not using 4 is not even used. Interface gigabit Ethernet 3. Let's go ahead and remove the legacy configuration, and let's use the named SRLG, which is red. Let's go ahead and commit the change, come out. Let's go ahead and verify the configuration one more time. Yep, 2 and 3, and they belong to the, and if you do this show SRLG just to quickly verify, yep, we have both 2 and 3 belongs to the same group, and you can see 3030. Now if you take a look at quickly the fast reroute, we should have now a backup path based on the SRLG, as we can see from here. So I have showed you both the ways of configuring the SRLG, the legacy mode as well as the new mode. And as you can clearly see, when you have the SRLG in work, it is just trying to avoid all the links that belongs to that SRLG group to figure it out an alternate path. And that is the whole purpose for SRLG, guys. If you think that there are some links that might have a shared risk or potential where one link failed could impact the other, and you want to avoid all those links, you are highly encouraged to say, hey, go ahead and configure the SRLG. And that's how you will go ahead and configure the SRLG using the legacy, which is not recommended anymore, but you can play around. The really way of implementation now is using the named SRLG, and I have showed you that also. So that's how you can go ahead and implement TI-LFA or SRLG. Again, when you have the SRLG or the node protection, those are applied at the global router level. So you go to your global configuration, under that you will go ahead and do that, while the links protection we have been doing primarily under the interfaces. So hopefully there are quite a few concepts, so you can go ahead and play around, build a lab and do some practical hands-on around the SRLG, and then see how this whole thing works. So that'll be all for this episode. I will see you guys in next episode, and probably will have the next episode in next week. As I indicated, I'm kind of busy with my current implementation. I'm working on a new implementation for a service provider. So there is a quite a hectic my schedule. I had a little bit of time, so I thought of recording. Again, I would encourage you guys to go over any of the previous topics or recordings. If you have any questions, feel free to post me those questions. I will be happy to answer any of your questions. So again, that'll be all for this episode. I will see you guys in the next episode. Thank you.